In example number 3 of our workshop today, we want to write in standard form and graph basically an equation of a circle. It's x squared plus y squared plus 4x minus 6y minus 23 equals 0. So essentially what I wanted to do was the following. I want to convert, the goal here is to convert the given equation into, the given equation into the standard form of a circle. And that standard form of the equation of the circle is given as x minus h squared plus y minus k squared is equal to r squared. Where in this format, in the standard form, you know that h comma k is the center point, and you know that r is the radius. Okay, r is the radius. So first, we have to take this given equation and we're going to apply the complete the square method to convert it. Right? So we're going to apply completing the square method. And here's how that works. So first thing is, you will take the given equation and you're just going to rewrite it. First line. You have x squared plus y squared plus 4x minus 6y minus 23 is equal to 0, right? Again, you're just rewriting the given equation into a new line. Then you are going to rewrite this equation now in anticipation of completing the square, okay? So what I need to do, essentially, is have my variable terms on one side and my constant term on the other. So if you look at this equation, what is my constant term here? Negative 23. So negative 23, I have to just push it over to the other side of the equation. So here I'm going to add 23 on both sides. So 23's here will cancel. This will give us x squared plus y squared plus 4x minus 6y is equal to 23. Now, again, I just have to do some sort of rewrite. I'm going to do some arranging. What I want to do here is rearrange this where the variable terms for x are sort of like grouped together, right? For example, we're going to have x squared plus 4x plus y squared minus 6y is equal to 23. Right? So from the very first line, it was just the given equation. Our second line, we move the constant over. Right? You want to have your constant on one side, the variable terms on the other. And the third line, you just did some rearrangement where the x terms are grouped together and the y terms are now going to be grouped together. Right? So I'm just call it rearrange for grouping. That's all. I'm not going to go too in-depth there. All right, so we're rewriting the reason for the rearrange for grouping purposes is so that way I'm doing this in the anticipation of completing the square. You see, the x squared plus 4x part, I could write it as x squared plus 4x plus blank plus y squared minus 6y. Oops, sorry. What happened there? So that's y squared minus 6y plus or minus blank is equal to 23. So the blanks now is where I have to find out. So I need to essentially complete the square now, right? To complete the square, there's a couple of things that I'm going to do. If I want to complete the square on x, I need to take half the value of b and square it. okay? Or half of the middle term, the coefficient of x, and square it, right? So if I want to complete the square on the x squared plus 4x part, what I'm going to do is take this value, 4. I am going to take 1/2 of 4, and then I'm going to square that value. So what's 1/2 of 4? 1/2 of 4 is 2. 2 raised to the second power is now 4. So x squared plus 4x, to complete the square on this part, we're going to say plus 4. So because I add 4 on one side of the equation, I'm also adding 4 on the other side of the equation, right? Whatever I do to one side of the equation, I must do it to the other. So I have to add 4. I'll show you how to do this again with the next portion of the equation. If you have y squared minus 6y plus or minus blank, you take 1/2 of the middle term. What's my middle term here? Or the coefficient of the middle term? -6. So I need to do 1/2 of -6 first. So what's 1/2 of -6? Say it louder. Careful. -3. But when I take -3 to the second power, this is, careful, 9. -3 times -3 is -3 squared, which is 9. So I have to add 9 on this side. So on this portion of our equation, it should say plus 9. So because I add 9 on one side of the equation, I have to add 9 on the other. All right. So we've essentially completed the square, and now I can do the factoring part. First of all, let's add these numbers on the right-hand side of the equation. What's 23 plus 4 plus 9? Say it louder. Louder? 36. Very good. So the last number should be 36. Oops. And now we got to take care of this piece. X squared plus 4x plus 4 plus y squared minus 6y plus 9. So the thing is, you have to factor this. Now, how good are your factoring skills with quadratics, factoring trinomials? Okay, let's practice here a little bit. So let's look at this. It's fine. Don't worry, we're going to practice. Let's look at the x squared plus 4x plus 4. You see, when you have a trinomial, look, you first begin with the term with the highest power. The term with the highest power is x squared, right? Your coefficient of x squared is what? What is the number in front of the x squared? It's a 1. So one of the rules regarding factoring trinomials is that if your leading coefficient here is 1 for your trinomial, the idea here is that when you look at this trinomial, try to think of two numbers that when you multiply them, that gives you your last number, the constant term, we call that our C, that adds up, those two same factors must add up to the middle number, which in this case is positive 4. So what are two numbers that when I multiply them, that gives me 4, yet still adds up to 4? 2, right? So this could be factored as x plus 2 times x plus 2. Now, how many factors of the x plus 2 do we have here? We have 2 of them. You see, when you multiply these factors, essentially because they have the same base, these binomials are the same, you can rewrite this a further by saying it's x plus 2 raised to the second power. Okay? Let's look at it again with the y squared minus 6y plus 9 until we get the hang of it. What are two numbers that when I multiply them, that adds up to, two numbers that when I multiply them gives me positive 9, yet it must add up to negative 6. That gives you positive 9, but adds up, negative 3 in itself, right? Because the last term is positive, the last term, which is positive 9, it's a positive term. and the middle term, which is -6, is a negative term, then the two factors must be negative. Negative times negative is positive, and then when you add two negative numbers, it always results in a negative number. So this will give you y minus 3 times y minus 3, which you can rewrite as y minus 3 to the second power is equal to 36. Okay? So here's your equation in the standard form now, which you can, so this is good. This is now our equation in the standard form. So what I can do is now identify my center point and my radius. Okay? Mm-hmm. Complete the square. That's how you complete the square. You take 1/2 of the middle term value, whatever it is, whether it was 4 or -6, and then you square it. Then you got to raise the resulting value to the second power. Okay, so here's our equation in standard form. Now what we like to do is graph the equation, but in order to graph the circle, I need to know my center and my radius. So what do you think my center is going to be? Go ahead. That's right. You see, when you have the equation of the circle in its standard form, just going back to the very beginning, it must be in the form of x minus h squared plus y minus k squared equals r squared. So at the very beginning where it says x plus 2 squared, you just have to do a simple rewrite. You can rewrite it as x minus -2, right? Essentially, you're just factoring out a -1 from that +2. The y minus 3, it's okay because it's in y minus k form, right? There's no y plus 3, it's y minus 3. And lastly, if you have 36s as your r squared, then what number squared gives us 36? 6, okay? So now you can clearly, you identified it for us. You said it, the center point is going to be -2, 3. Your radius is going to be 6. All right, so now I have enough information to make my graph. So here's how I make the graph. Let's say here's my y-axis. Let's say here's my x-axis. First thing is I could plot my my center point. My center point was -2, 3. So what quadrant would be the center point be located in? Quadrant 3. There you go. So here's the origin. You move 2 units to the left, followed by 3 units to the right, 3 units up. So here's my center point. Now, you can use the definition of the radius to help you get some other points that are actually on the circle's boundary. By the definition of the radius, it's a measurement. It measures the distance from the center to any point on the circle's boundary. So from our center, which is -2, 3, I can move that center point or translate our center point 6 units up, 6 units down, 6 units left, and 6 units to the right to get some 4 key points on the circle. So for example, if I went 6 units up on the y-axis, what would be 1 point on the circle's boundary if I went 6 units up? It would have the y value of, well, what about the x value? -2. The x value stays the same, but the y value would have been 9, right? So if I went up 6 units, 1, 2, 3, 4, 5, 6, you're going to get -2, 9. Now, if I start back again at the center, and I went 6 units down this time, the x value is still -2, but you got to subtract 6 from the y value. Not -6. Remember, we're at -2, 3, -3, right? 3 minus 6 is -3. So here's 1, 2, 3, 4, 5, 6. This is -3. Now you have to do the left and right case. If I went 6 units to the left, right, the y value wouldn't change. So 1, 2, 3, 4, 5, 6. This would be -3, -4, -5. Sorry, -3, -4, -5, -6, -7, -8. And then you went 6 units to the right of your center. So 1, 2, 3, 4, 5, 6. Now this wasn't drawn to scale, so I might not get a perfect circle. Yeah, I totally didn't get a perfect circle, but I was hoping. I still didn't get a perfect circle with the change, but it's fine. But that's how you complete the circle. It's just that yeah, it's just that the scaling is off. If you look at my scaling, it's kind of off, so it's okay. I'm just gonna leave it like that. Ta-da! That's our circle. You're gonna get a more nicer circle on MyLab, for example.